smallest positive integer n with this specific property. We have three consecutive integers starting at n+2, taking their product, and we want to find the smallest n such that that is a multiple of 493. Now 493 is kind of customized for you here. It turns out to be the product of two distinct primes, which I think helps out quite a bit here. Now, absolute value makes an unexpected appearance here. This key observation right here, let x be the factor which is divisible by 17. And y'all, by factor, let me write that down here. By factor, I just mean, hopefully it's self-evident what I mean by factor, but just in case that's not clear to you, by factor, I just mean any one of these three factors up here. That is, I mean something in this form, n plus j. Or let's say n plus I, whatever, n plus I, and I is equal to 2, 3, or 4, okay? And I don't think most of you needed that, but just in case. And the spacing too, there's only going to be one x that's divisible by 17 just due to the spacing here. They're all within 2 of each other, which is this key observation here. So y is also the factor which is divisible by 29, and these are the two distinct prime divisors of 493. So now, and just by, it's evident that they are no further than 2 away from each other. Okay, so the absolute value, it's kind of cool how that comes into play here. So we're going to run through all these possibilities, and it's really very systematic and kind of cool. So I start with the first multiple of 17, which is 17. And notice these are the y's that are within a distance of 2 of 17. Notice 17's in the middle right here. And guys, this is neat. This is all the way to like algebra or something where you know the absolute value. The absolute value function, I don't know, let's say like this. Okay, and let's say that we're at 17 right here. Not scaled in any kind of particular impressive fashion. See how this would be the absolute value function, x minus 17, I guess? Absolute value of x minus 17. Isn't that neat? So you see, you got some symmetry here. Obviously, it's centered at 17, and then 18 or 16 would be here, right? You see how we got 16, 15, 16 would be here, 15 would be here, 18 would be here. And so we got that going on here. Now, what are we looking for a while? We're looking for a multiple of 29. Well, there's no multiples of 29 in this first row here, right? These are all of the y's that are a distance of 2, which is guaranteed just by how these are consecutive integers, okay? Now, so let's check out the next multiple of 17, which is 34. And again, you'll find 34 in the middle. We're looking for a multiple of 19. We don't find one, right? 31, 32, 35, and 36 are not multiples of 29, whatever I said a while ago. All right, the very next one, 51, that's the next multiple of 17. 51 in the middle, again, 49, 50, 52, 53 is not a multiple of 29. You got to keep going and hope you run into it. I guess that's guaranteed by something, But now 68's 4 times 17. 68's in the middle, again, no multiples of 29 here. 66, 67, 69 is not, 70 is not a multiple of 29. And so finally we get to the promised land right here. When you get to 85, 85's in the middle, and you get 87 is your last number here, which is equal to 3 times 29, right? 3 times 29 right there, okay? All right, and so you see we're guaranteed to have the multiple of 17 in the middle, right? So that's done with, and we got a multiple of 29 right here. Okay, so that means the product, if you just equate, what do we need here, folks? We need to put 85 here, right? 86 consecutive integers, right? And then we put 87 right over here. And that's slick. And so this statement would imply that n has to equal to, any of the statements would imply that n has to equal to what, 83? So n is equal to 83. And this 83 is just kind of incidental right here. This gets it done. You see, notice that if 84 happened to be a multiple of 29, or if 83 happened to be a multiple of 29, but neither of these guys are multiples of 29. 87 is the first multiple of 29. Okay, so you got to be slightly cautious on these kind of problems. So we actually are equating 85 right here, but if 85 is equal to n+2, that means n has to equal to 83. And of course, that would still make this, this would be 85, 86, and 87, right? So you see, this would be the one that's a multiple of 27. This one would be the one that's a multiple of 17, right? So that means this is some multiple. This is equal to, we could write it out specifically, I guess, but this is going to be a multiple of our original goal here was what, 493, okay? So this is equal to 493 times some multiple. Well, we'll just say it like this, 493m, right? Because again, this is guaranteed to be, this is divisible by 29 because it's 87. This is divisible by 17 because it's 85, right? And so that means 17 times 29, which is 87, has to be included. I mean, the guarantees this statement right here. So folks, we have proved what we set out to prove, okay? It's a multiple of 83, and the answer is n equals to 83, and it's the smallest one, right? We check, and if I made it, I could have made a mistake up here somewhere. If there is a multiple of 87 that I didn't, or 29 that I didn't spot up here, then this is wrong. But I'm pretty sure I don't think any of these guys here are multiples of 29. So this would be the first row where we get our multiple of 29. Hence, n equals 83 is our answer. Okay, so that completes it. Let me come up here and just write it. That would be n equals to 83. And there's no need to check it. You can check it if you feel like it, but it's guaranteed to be a multiple of 493 just by the construction that we did right here. And again, to me, the highlights of this one is the fact that absolute value came in very, very handy. Just this option, these divisors had to occur somewhere, and you also know that they could be separated by no more than 2. And so you get this range of candidates for y, and then you just keep sifting through until you find a multiple of 29. All right, that does it.